Hi boys and girls. Today we're going to do our lesson 3, and the title of this lesson is called Dilations with No Grid. Our goal today is we're going to dilate figures that are not on grids. Whenever we're done today, you should be able to apply a dilation to a polygon using a ruler. So let's get started on our first activity. Our first activity is called points on array. Okay, so our activity called points on array, if you will look at number 1, we are going to find the point, find and label a point C on the array whose distance from A is twice the distance from B to A. So we have this ray AB. And so we want to find and label a point C on the ray whose distance from A is twice the distance from B to A. So if we look at the distance here from A and B, whatever this measurement is here, I want to double it. So I could possibly measure it with a ruler, or I could just use some paper and do some markings. So I am, for the sake of time, I'm just going to use my paper here, and I'm just going to make a mark here and make a mark here. And then in order for me to double AB, I'm going to slide it down here, and so now it's double that length. And so here's my marking here, so I'm going to place my C on this segment, on this line. So I'm going to label that as C. So on your paper, make sure you're able to do that. All right, for question number 2, it says to find and label a point D on the ray whose distance from A is half the distance from B to A. So if you look at the distance of A and B again, and I'll just use my marker again, I have this distance here. We can either, again, we can use a ruler, or we can just estimate the halfway point here between A and B. And so here is where you would label the point D. And you have completed that activity.
Hi guys, Mrs. Wallace here. So we're going to be doing the second activity called Getting Perspective. And if you have a ruler, it would be very helpful, or you can keep using a little piece of paper, a sticky note, a index card, something that you have as just to use as a straight edge. But I'm going to use a ruler. So here are directions. Using one colored pencil, draw the images of points P and Q using C as the center of dilation and a scale factor of 4. Label the new points P prime and Q prime. So we're going to do that first. You've got this little image, and I'll give you a couple of seconds to just copy down something similar in your notebook. So the reason that it would be helpful to use a ruler is because we need to use a scale factor of 4, meaning whatever the distance is between C to P and C to Q, we need to multiply it times 4. So I'm just going to draw a nice straight line. C is my center of dilation through point P. I don't know how far out quite yet that I need to go, but I'm going to draw this straight line to help me. Now, you could use your paper, like I said before, like Miss Looney did, figure out the distance between C and P and do it 4 times. You could use multiplication. So this is about 1.25, 1¼ inches long. And I'm just going to do 1.25 times 4 because I know that that is the, it's asking us to do a scale factor of 4. So 1.25 times 4 is 5. So right about here is where I need to plot my new point and label it P prime. And then I'm also going to do the same thing with Q. So I'm going to draw a straight line starting at C through point Q. I don't know how far I need to go quite yet. C to Q is about 1.75. So again, you could take a little piece of paper and take whatever the distance is 4 times over, or you could do 1.75 times 4 since that's my scale factor. And 1.75 times 4 is 7. So this is going to be Q prime. Now, I know it said to do it in a color pencil, but I just used a regular pencil. And now I'll be doing it in a different color, the second part. Question 2 is, using a different color, draw the images of points P and Q again, using C as the center. But now our scale factor is 1/2. Label the new points P double prime and Q double prime. Okay, so instead of going out 4 times, we're going half of the distance. So I know I'm going to be going back some of the distance. So I'm still on the same line using C as my center and P as my point. And since my scale factor is 1/2, you could do 1.25, divided by 2, multiplied by 1/2, or just estimate about a halfway point. And that's the line. And this is P double prime. And same thing with Q. So I'm drawing my line again from C to Q, but I need to estimate about halfway. So let's say about here. Now that is Q double prime. So your image should look something like that when you are done both sections of the problem. You have a line going from C through P double prime, P, P prime. You have a line going through C to Q double prime, Q, and Q prime. So, some takeaways from this activity. What are the effects of using a scale factor greater than 1? So, P prime and Q prime were my scale factor using it greater than 1. Well, the image becomes larger than the original and it's farther away from the center. What are the effects of using a scale factor of less than 1? Well, the image is smaller than the original and now it's closer to the center of dilation. So that was our P double prime and our Q double prime. And what effect does the location of C, the center of dilation, have? That center is going to impact your size and your location of that dilated image. And the key ideas here are pretty much the same thing, just worded a little differently. Center of dilation, the point being dilated, and the image must all be on the same line. So if we look back at our picture, the center, the point, and the images being dilated all have to be on that same line. Same thing with Q, center, point, and the images being dilated all are on the same line. A scale factor of 1 does not move any points. If the scale factor is not 1, only 1 point does not move, which is that center of dilation.
Hello all, this is Miss Bryant, and we're going to look at our last activity for today, which is Let's Dilate. So here we have triangle ABC, and we're going to dilate this shape using point A as the center of dilation by a scale factor of 1/2. So point A is my center, and my scale factor is 1/2. So if I look at each one of the sides of this triangle, I'm going to recreate a new one using 1/2 as my scale factor, and it's all going to be around point A. So if I look at AB, scale factor means of 1/2 means I'm going to cut this shape in half. So what I would have to do is you can actually measure it out or make a good estimation as to where halfway between A and B would be. So let's say right here would be that halfway mark between A and B. Okay. Now I'm going to look at A and C, and again, I can either measure it out and get exact, or I can make a good estimation as to where halfway between A and C are. And this looks like a good spot for halfway in between. And then I connect my 2 points. And here, I have created my dilated shape using point A as my center and a dilation of 1/2. And as you can see, what ends up happening is I end up creating a triangle within a triangle, which is called an embedded shape. For our next example, we're going to dilate triangle ABC again, but this time I'm using point B as my center, and I'm using a scale factor of 1/4. So I'm no longer working around A, everything's going to be around B, and I'm going to use the same technique, same idea as I did with the first shape. So looking at segment BC, I need to cut this up, into fourths. So for some of us, measuring it would probably be helpful, but then for some of us, again, measuring it may not. We can probably do a good rough estimation. So you could measure it out. So it's roughly 10 centimeters and almost 4 inches. So what I'm going to do is I'm going to do a rough estimation. So if this is halfway, then this would be halfway in between half. That would be halfway in between half. So here is 1/4. Then on the other side, AB, I'm going to do the same thing. If this right here is my rough estimation of a half, then halfway in between a half would probably be about right here. Then I connect my 2 dots here. And here I have my dilation of my triangle A, B, and C by a scale factor of 1/4, with B being the center. So again, this one created, like the first one, a triangle within a triangle, which is known to be called an embedded shape. For our last example, I'm going to use point C as my center. So I'm going to be working around C, and my scale factor is going to be 2. So that means, or that's telling me that my sides are going to be twice as large as the original. So if I'm working from C, if I look at BC, this is how long BC is. My scale factor of 2 says I need to double this. So if I'm going to double it, I could measure it out. That could help me. Or again, I can do a rough estimation. So if I use my 2 points here, my hand and my pencil, lift them up, shift them over, put them down. That'll give me a fair idea. Or this time, let's see. say if we measure, or this one was actually just measuring instead of rough estimation. If I measure this, it's this long, right? Second line right before the 4. So I'm going to move it to the top where B is, second line right before the 4. And I'm going to draw the rest, or my extended part of my triangle. So that's that side. All right, now for AC, I'm going to do the same thing. I'm going to extend it out. As you can see, this ends up extending further than what my paper is. So measured, this is about 6.5. So lining up the end to here, I'm going to do about 6.5. As you can see, this extends really far and extends off the paper. And then I'm going to connect my 2 points here. So all of this becomes a part of my dilation when I do a scale factor of 2. So looking at our last picture, let's see if we can get the other 2 back in here so we can look at them and compare them just a little bit. So if we look at our pictures, when we did when we had a scale factor of 1/2 or 1/4, as you know, it kind of shrunk the picture and it pulled the picture closer to the point of dilation. When we have a scale factor that is a whole number or greater than 1, you notice that it takes the image away from the center. You see that the picture started to move out. So one very important thing that we need to remember and keep in mind from this activity is when we're doing a dilation that has a scale factor that's in fraction form or less than 1, you'll see that it kind of pulls it closer to the center of dilation. And then those shapes that has a scale factor that is greater than 1, you'll see that it pulls the image away from our center of dilation. Okay. Hopefully, after today's lesson, you have a better understanding of dilations and how to actually dilate on these figures and on figures that are not necessarily on a coordinate grid. If you have any further questions about how to do what we did today, feel free to contact your math teacher. If you have any questions, again, contact us. Thank you and have a great day.